Assalamualaikum and good day. You're with me again, Miss Huda. In this recorded video, we're going to learn on the topic of moment of inertia. At the end of this lecture, the students should be able to understand the concept of moment of inertia and theorem of parallel axis, able to calculate the second moment of area of common geometrical section, such as rectangle, triangle, circular, L shape, T shape, and I section shape. When the forces are distributed continuously over an area on which they act, it is often necessary to calculate the moment of these forces about some axis either in or perpendicular to the plane of the area. Frequently, the intensity of the force or pressure or stress is proportional to the distance of the line of action of the force from the moment axis. That's why we call it moment of inertia. The elemental force acting on an element of area then is proportional to distance times differential area, and the elemental moment is proportional to distance squared times differential area. You will get the idea bila kita tengok the formula later. Moment of inertia, also known as second moment of area, is denoted by I. So kita akan pakai I simbol. Second moment of area of plane figure is the product of the area and the square of the distance of the centroid of the area from the reference axis. It is called second moment of area because moment of area is taken twice about the reference. The units that is commonly used for moment of inertia is mm to the power of 4, cm to the power of 4, or m to the power of 4. Let's look at the theorem of parallel axis. It states that the moment of inertia of a lamina about any axis in the plane of the lamina is equal to the sum of moment of inertia of lamina about its centroidal axis parallel to the given axis and the product of the area of the lamina and square of the perpendicular distance between the two axes. So to get the idea, let's look at the formula. If you are calculating the inertia at axis A and B, as per example here, it should be equal to the inertia at the gravity line here plus with the area, which is the area of the section that we calculate, and the distance from the center to the axis AB and power of 2. So that is basically that you need to understand about inertia on the formula. The moment of inertia is a property which measures the efficiency of the shape in its resistance to bending. So that is mostly what it is used for. The moment of inertia takes no regard of the strength of the material. It measures only in the manner in which geometric properties or shape of section affect its value as a beam. Sebab kalau you just ambil kira area, it doesn't really matter shape tu rupa dia macam mana, asalkan area dia is a big value dan you ingatkan the value is enough. Okay, they tak take into regards the shape of the object, but what we need to know is the shape of object also affect the efficiency dalam resist the bending. That's why bila kita kira I-axis, for example I section, okay, dia lebih tinggi inertia dia walaupun the area sama saja dengan the rectangle section, but I section is more efficient. Steel I-beams, which are commonly used as a structural members to support various load, offer good resistance to bending, and yet they use much less material than beam with the rectangular cross section. Okay, ini adalah salah satu sebab. The beam will offer much resistance to bending moment when fixed as figure 1 compared to figure 2. That's why bila kita install beam, we always install it vertically like this, not horizontally like this. It is much weaker in this position. This is because the moment of inertia about the x-axis of bending is larger than moment of inertia about the y-axis. Kita akan belajar calculate untuk x-axis and y-axis, and we will know that the I-axis for this shape is much bigger compared to the IYY in this manner. The formula used in the calculating moment of inertia, the neutral axis, which exists at the centroid of the shape or structure. So this is the neutral axis. Basically, it is exactly at the centroid of the shape. In this instance, this is I section. For any rectangular shape, for example, you have one rectangular like this. The formula will be BD cubed over 12, which is B is this one, and the depth. Power of 3 divided with 12 plus the area, so total area of the beam, and distance from centroid to the point yang you tengah kira the inertia ke titik mana. For example, kalau you tengah kira ke axis AB di sini, means that H will be this value. And for IYY, it will be the other way around, yeah. So DB cube over 12 plus AH square. So D will be the height here, and B will be the breadth here. Power of 3 divided with 12 plus A times with H power of 2. So H here, for example, if you are calculating the inertia to the axis C and D, therefore H will be from the centroid to the axis CD. For hollow rectangular shape, you can use this method rather than to calculate semua sekali, ya. You can just take the bigger rectangle, get the value of I-axis, and minus with the smaller rectangle inside the value of I-axis atau IYY dia lah. Then basically you akan dapat this part. And same goes with IYY. So you have to terbalikkan lah. It become DB cube divided with 12 minus DB cube divided with 12. And for circle, it is similar for I-axis and IYY sebab dia symmetry. So pi d power of 4 divided with 64. That is the formula. And you can have a look at this table. This is the summary of the formula for inertia. You have one for the rectangle. So basically here dia tak masukkan lah that AH square sebab kalau you memang betul-betul kira inertia to the center axis here, meaning that you take the axis betul-betul dekat tengah, H dia akan jadi kosong. So tiadalah AH2 ni. Okay, depends on point of reference. Kat mana sebenarnya point of inertia tu you ambil. Okay, kalau dia betul-betul dekat centroid, meaning H akan jadi kosong. Tapi kalau dia kat bawah ni, dan satu lagi kat sini ada value ya. So ada AH square for both IXX and IYY. And for hollow rectangular section, as what I mentioned in the previous slide, for circular section also similar like I mentioned in the previous slide. And if you calculating for the hollow circular section, basically what you do is the same. You calculate the IXX and IYY. The value will be similar for the outer circle, and calculate the IXX and IYY for the smaller circle inside. And you minus those two values. And for others here, and for I section, it's going to be a little bit complicated. We have to divide it into a few sections to make it easy for us untuk calculate compared to if you pakai this method. But still you masih boleh pakai guna minus sebab you ada value yang you akan tolak. Sebab you akan tolak this value, you akan tolak this value. But it is much easier kalau you kira satu-satu like this. Take this one section, second section and third section. And kita akan buat example after this. And for triangle, the inertia at the center of gravity, meaning betul-betul dekat tengah ni, will be BH power of 3 divided with 36. So all this formula yang critical yang you kena hafal adalah ini ya. Sebab yang lain-lain adalah mostly adalah application. But based on shapes, the rectangle, the circle and the triangle that you have to memorize. That will be all for the introduction video. Thank you so much. Have a nice day.